Hello, welcome to lesson 6H. I can use the appropriate ratios to find surface area and volume of similar figures. All right, so just like with a similar polygon, our similar solids have the same shape with all of their corresponding dimensions in proportion. So I want us to do a little exploration first where we look at different types of measurements you can make on three-dimensional figures and how two similar figures relate. So let's take a minute and start with the perimeter of the base. Well, if you look here, the base of this figure here is a square. It's a 2 by 2, and 2 times 4 would get me a perimeter of 8 units. Whereas here, my perimeter here is 4 times 4 plus 4 plus 4 plus 4, or 16 units. All right, now let's look at the area of the base. The area of the base is length times width, or 2 times 2, which is 4 units squared. Whereas the area of my large prism is 4 times 4, which is 16 units squared. Now let's take a look at surface area, okay? So my surface area of my small prism, well, I've got two 2 by 2 rectangles and 4 3 by 2 rectangles, which means we have a total area of 32. So the surface area of my small prism is 32 units squared. Now let's look at the larger prism. My larger prism has SA of large equals 2 4 by 4 faces, those are the top and the bottom, plus 4 4 by 6 faces. And my 4 by 6 faces, all that's going to add up to 128. So 128, ooh, that did not write the way I wanted it to. Let's try that again, friends. 128 units squared. Okay, now let's look at volume. If we recall, for a prism, volume equals area of the base times height. So the volume of my small prism is going to be the area of the base, which we already found is 4, times the height, which is 3. So my volume is 12. So we get 12 units cubed. And now let's look at the volume of the large. Volume of the large is going to be the area of the base, which is 16, times the height, which is 6, or 96. So that's 96 units cubed. And what I want us to do now is to look at the ratio of each of these. So let's start off with perimeter, right? We did perimeter before, but we're going to do it again right now. So the ratio of perimeter, small to large, is 8 over 16, which is 1 over 2. And if you look, that's the same ratio that the sides are in proportion to, right? The 2 corresponds to the 4, that reduces to 1 over 2. So that is my A over B relationship. Area, as we saw before, area of the base, is a 4 over 16, or 1/4 ratio. Well, just like we saw on the last lesson, that's my A squared over B squared ratio. Now let's look at the new things. Surface area, we're in a ratio of 32 to 128. Well, when you simplify that 32 actually goes into 128 4 times, so that again is a 1 over 4 ratio, or A squared over B squared. And then volume, we get 12 over 96. Well, 12 actually goes into 96 8 times. So that's 1 over 8. Well, if we start with a 2, 2 cubed is 8. So that's my A cubed over B cubed relationship. So the ratio of corresponding surface areas, if we have a scale factor of A over B, is A squared over B squared, while the ratio of corresponding volumes is going to be A cubed over B cubed. So this is the big idea here for this lesson. Those are the ratios of the surface area and the volume. Now let's look at some examples. There are 2 similar cones, one of which has a volume of 250 pi feet cubed, the other with a volume of 432 pi feet cubed. What is the scale factor of the smaller figure to the larger figure? Okay, so I want to do small over large if I want smaller figure to larger figure. And so I'm going to take the information they do give me. 250 pi over 432 pi. And I'm going to reduce this first in whatever way I can. Well, here my pi's cancel and I can actually divide both by 2, which gets me 125 over 216. Well, this ratio has to be the same as their scale factor cubed, a cubed over b cubed. Well, when I take the cube root of both, and I'm going to show you guys how to do that in your calculator right now. Okay, so learning how to figure out if something is the cube of something else. The way I'm going to do that on my calculator is you've got this button over here. That's the in root x button. It's in blue. Well, I'm going to hit Control in root x, and I want to cube root it. I don't want to square root it. I want to cube root it. So I'm going to put a 3 right there. And then I want to see what the cube root of 125 is. That's 5, which means that 5 times 5 times 5 is 125. So that's what it's telling you. So let's look at the other one that's a little bit harder. I'm going to hit Control, whoa, not what I wanted, friends. Control in root of x. I still want the cube root, but this time I want it of 216. When I do that, I get 6. Well, so that tells me that 6 times 6 times 6 is 216. So coming back over here to our work, I know then that a over b must be the cube root of this thing over here. That's 5 over 6. Okay, so that means that my scale factor is 5 over 6. Now let's talk about the ratio of their surface areas. Well, remember the ratio of their surface area, we learned from up here, has to be a squared over b squared. Well, if a over b equals 5 over 6, well, then I want to square both sides to get a squared over b squared. So a squared over b squared must be 25 over 36. That's the ratio of their surface areas. Now let's look at our last example. A cylinder is similar to a larger cylinder. The scale factor is 1/3. Well, scale factor is a over b. That means a over b is 1 over 3. And the surface area of the smaller cylinder is 30 pi. The volume of the smaller cylinder is 24 pi. What is the surface area and volume of the larger cylinder? So let's start with surface area. So surface area is in a ratio of a squared over b squared. So when I square my a over b, I get 1 over 9. That means that 1 over 9 must equal, well, they tell me the surface area of the smaller cylinder is 30 pi. So 30 pi is going to go in my numerator because with my ratio over here, the smaller number's in the numerator. And I'm hunting for x. I'm hunting for the larger surface area. So we cross multiply. I get that x equals 9 times 30 pi is 270 pi units squared. Okay, now let's look at volume. Well, volume is always in a ratio of a cubed over b cubed. So that means I cube this fraction here, I cube my original scale factor, and I get 1 over 27. So I'm going to set up my ratio. 1 over 27 must equal, they tell me that the volume of the smaller cylinder is 24 pi. So I put 24 pi in my numerator over x in my denominator. And I'm going to cross multiply. I get that x equals 24 times 27 is 648 pi. It's going to be units cubed. So guys, to solve these problems, you just really utilize the scale factor ratio, and it makes it pretty easy. If they don't give you the scale factor, but they give you, say, 2 surface areas or something like that, like they did up here, 2 volumes, we simply use that to work backwards to find the scale factor. Then once we have the scale factor, everything gets really easy. So that's how you tackle those. All right, guys, go ahead and try the MML, and we will see you.